So not everyone has the space or the money to do full camera tracking and virtual production and all that kind of stuff, especially if you're, say, a student just starting out, wanting to learn the ropes. So to lower the barrier of entry, I guess, I took my Blueprint Toolbox plugin that you can get on Gumroad, and I added a additional feature to it, and that's this Encode 3D data. Now, if you've never heard of 3D before, what it is I guess the bare minimum to track a camera in 3D space. So it was done by the BBC as well as, I think it was Witten in the 1990s to control the robotic cameras in the BBC News studio. Since then, it's sort of been reversed, and rather than controlling a robotic camera, it's used as a protocol for cameras to send their tracking data back to virtual things like Unreal. So I have it here. It's really simple. So we've got a camera ID 0 to 255 cameras at any given time on the same network. The location, this one's in Unreal units, rotation, the zoom, and the focus, which is about everything you should need. One thing to note is because the 3D data is encoded in a 3-byte integer, signed integer thing, there is a physical limit to the amount of, I guess, distance that can be covered, and that's about 250 meters in any direction. So negative 250, positive 250 on the X, on the Y, and on the Z. Just something to keep in mind. Technically, the zoom and focus would also have a similar limit in the 2000-ish range, but I have never, well, I guess a 2000 millimeter lens does exist, but I don't think we're gonna run into that issue there. Now that is a problem with the 3D, I guess, standard, nothing to do with how this plugin was written. So, what it gives in return is an array of bytes that we can do something with, essentially send it over the network to another Unreal Engine. And that's what the focus of this tutorial is going to be. Now to do that, we're going to need a couple of plugins. First of all, my Blueprint Toolbox plugin you can grab off Gumroad free of charge, as well as the Socket.io and UDP wrapper you can get from the GitHub link below. Now, if you don't want to go through all these steps, I'm going to be putting this project up on Gumroad with a handful of extras added as well, for anyone that wants to skip that process. Otherwise, I will show you how to set it up completely. So, the way I want to do this, is as seamless as possible, and so much like how we add the live link component to our camera to receive tracking data, I'd like to do the same component method to send out tracking data. Should be pretty straightforward. So let me delete that. What I'm going to do is create a new folder and call it camera emitter encoder, I guess. I'm going to create a new blueprint, and I'm going to make it an actor component, and I'm going to call it a BPC because it's a component. Camera encoder. We'll keep it simple. Now, the way this works is we're going to also need a UDP component. So I can demo, I'm going to just demo it in a simple blueprint BP test, I guess. And so we can create this UDP component. Now, UDP is the building blocks of a network. The other common one is TCP, you may have heard of. Now, TCP is a send and response system. So a TCP connection, you sort of send a bit of data and you expect it to respond and say, I've got it. And if they don't, you send it again and again and again and again and all that good stuff. UDP, however, is just more like a fire hose. It just spews data out at anything that will listen and doesn't care if it's received it or not, which is exactly what we want for camera tracking. So each frame has a new bit of data, and because of that, we don't really care if we skipped one 10 frames ago, because that was 10 frames ago, we're finished with it. So whether TCP might be like, oh, you missed one, let me send that back, and we get like this jitter of back and forward. UDP will just keep going and going, and if you miss one, you miss one. Who cares? So the way this UDP component works is we have, if I click on it, we have some settings here. So I can specify an IP address, a port. We're going to skip the receive side of it because we won't be receiving anything. We've got a socket and a buffer size, and should it open or not automatically. So on event begin play, I want to add that UDP component to our component, I guess. So I'm going to type add component by class, and then I want it to be that UDP component, like so. I'm going to get parent, get owner. So I'm not adding a component to a component, I'm adding a component to whatever this component is attached to. So I need to get the owner and set it as a target, which will then shut that message up. I'm going to save this so the garbage collector does not steal it from me. Like so. Next, I'm just going to close the socket. Close send socket and close receive socket. So by default it starts immediately doing something, and I need to essentially close it, change my settings, and then open it. I don't think this is really designed for being added this way, but it will work. Alright, there we go, close, close, close. The last thing I need to do is grab an event and event end play. And I also need to close it on end play so that it doesn't sort of create a ghost thing, ghost UDP socket that's just floating around in the ether when we're finished. Close send socket. Alrighty. Now I need two variables. The first one is going to be the send IP, which I'm going to make a string. Whoops. Like that. I'm going to make it public so that we can edit it and don't need to hard set it here. The other one I'm going to do is the port. Whoops. And this one's going to be an integer. Same thing, public again. Now I'm going to get my UDP component. I'm going to set this value. So set send open send socket. So I'm going to open the send socket again with the new data, like so, and then on my IP address and my port, I'll do that and that. The default for the IP address I'm just going to set as localhost, so 127.0.0.1. For the port I'm going to set to Unreal's default, which is 40,000 for live for 3D over live link. So we've created our component to send the data. We have opened it to start sending data. Now all we need to do is send data. So I'm going to go ahead and grab this get owner, and I'm going to get the actor transform. Okay, it's position in 3D space. I'm going to grab my encode 3D data and split it. Oh, let's put this up here somewhere. Out of the way, there we go. Also going to split this one. I'm going to plug the location and rotation into there. Might expose another integer and call it the ID. So plug it into there. Alrighty, so last thing I need is the zoom and focus. So what I'm going to do is I'm going to I'm going to get component by class. So, and I'm going to search cine camera component like that. this will hopefully return the cine camera, but I need to be sure, so I'm going to do a is valid. Like, oh, actually, you know what? Let's do this one is valid. So if this returns nothing, which means we don't have a cine camera, then we can still encode the tracking data. We just won't bother with the zoom, and so we won't, instead of getting an error, it'll just return the zooms as 0. So I'm going to go select float and select float on both of these, and the pick A is going to be the is valid. So if it is valid, then we're going to use the A, and if it isn't, we're going to use the B, and I'm going to leave the B as 0. So now that we have our cine camera reference, hopefully, I'm going to get the focus, current focus distance, and plug that into the bottom one. Yep. So A, I'm also going to get the current focal length, and that can go into this one. So let's put it like that. Try and be neat about it, ideally. Lastly, I need to grab our UDP component. So now we've encoded all the information we need about our virtual camera. All I need to do is send it. So I'm going to grab our UDP component, and I'm just going to type emit bytes, plug it into the event tick, and plug the result into bytes, and we're done. Compile and save it. So let's give it a crack. I'm going to go ahead and open a second Unreal to test it out. Alrighty, in my second Unreal instance, this is going to get a little confusing, but I want to make sure that I have the both LiveLink plugin, like that, and the LiveLink 3D plugin enabled. Yep. So I can receive the tracking data. Now, in my plugin, I did also include a decode 3D data. This lets you take the bytes and decode it back out, but I would recommend sticking to the LiveLink plugin for that purpose. Don't try and, I guess, make your own version of LiveLink. So now I'm going to put that there, and I'm going to put that there, and let me go basic. Alright, I'll put some labels up, but on the right hand side is our transmitter, on our left hand side is the receiver. So on the transmitter side, what I'm going to do is I'm going to go ahead and add a cine camera actor. Oops, like that. And then I'm going to add our BPC camera encoder, like so. Let's set that to 1. Nope. Now on the other engine, I'm going to go ahead and open the LiveLink window, Virtual Production LiveLink. Going to make a source. I'm just going to type 0.0.0.0. So that means anything sending to this computer will be received. Now, if I go ahead and hit play on this computer, we can see camera 1 shows up. So what I'm actually going to do is slightly different. I'm going to use simulate, because then I can use like that, and I can't see it, so I could, there we go, unhide it, and now we're sending tracking data, or should be sending tracking data. Now on the other engine, I'm going to go ahead and add a cine camera again. I'm going to go to details, I'm going to add a LiveLink component, I'm going to choose the camera, and now, nothing. I betcha it's because use less CPU is on one of these. Use less CPU, no. Alright, it seems to be working. I think when I was unhiding the mesh, yeah. Okay, doing that in game mode causes the object to reset, I think. Which is a bizarre one. But then, because it's still in game mode, the begin play never runs and it never has that or something. But if I don't do that, then it works fine. So you can see as I move it around, we get it in there as well. So if I made a level sequence quickly, cinematics, level sequence, underscore, test. Let's add the cinecam, and let's transform, and then like that maybe, like save, drop that in there, just say loop indefinitely and autoplay, and then hit play. And what I should then get, I turned off use less CPU in background, but I think it's still somehow on. Use less. Yeah, that's weird. There you go. So you can see it's moving. Trying to do this on two PC, the same PC at the same time is not recommended. However, you can see now how this could be used across multiple PCs. And if you use NDI, which is a network video standard, then you don't even need any of the SDI capture cards. You just need two computers connected via Ethernet that can run Unreal. Now there's one more piece of the puzzle, and that is lenses. Now if I go ahead in this animation and let's just animate the lens to say 100. Now what we're going to need is a lens file on our other machine to interpret that data. So to do that, make sure that the lens camera calibration, that's the one, is enabled. Go ahead and restart it. Yes. Like so. I'm just going to really hope this isn't confusing with which Unreal is which. Alright, so now that we have our lens calibration, we're just going to make a quick lens file. So that's under miscellaneous lens file lf_unreal. Now the way the 3D plugin in LiveLink works is quite straightforward, or sort of. Alright, so the way lens data gets represented, and we can look at it in here, is if I go to my focal length encoder, you can see the numbers has a min and a max. And if I reset these, if I go use manual range, then reset, and then untick, you can see as my camera is animating, they go up and down as well. That is because the 3D plugin takes the smallest value it's ever seen in its lifetime and the largest value it's ever seen in its lifetime and translate that into a 0 to 1 range. So 10 millimeters, 35 millimeters becomes 0 and 1. Now because of that, we need a lens file that then says at 0 it's 10 mil and at 1 it is 35 mil. This is where our lens file here comes in. So if you've ever been on a AR production before, you'll hear people say you're doing your lens limits. That's just basically zooming all the way in as far as you can, all the way out as far as you can to generate that 0 to 1 range. Now, in my lens file here, all I have to do is go to focal length and add a new one. Under input, focus, and zoom, I'm going to leave them at 0. And under FXFY millimeters, I'm going to set it to my minimum value, which in this case is 12. 1200. No, sorry, it's 12. Input there, 12 and 12, add, and then I'm going to set it, the maximum is 35. So there, I'm going to put on the zoom, I'm going to type 1, and then I'm going to do 35 and 35. Now, it generates a curve because the lens sort of doesn't linearly zoom. However, in Unreal, it does linearly zoom, so I need to make sure I convert this to a linear value like so. Now, if I go back to our test map, so here's our camera, I loaded a different animation. So all I need to do is go lens and add the lens in, and then add the lens file, and you can see we are getting zoom values. Or it should. Made a liar out of me. Oh, there we go. So it's moving, and then it's zooming. Cool. So one issue you may come across is the zoom, especially looking very jittery, as seen here. So we can see it's like jumping out, which is not quite what's happening in the real world. In the real world, it's a very smooth zoom out, very smooth zoom in. The reason because of this is 3D encodes everything as integers. So if we go back and have a quick look at our code, we're encoding the focal length and the focus distance directly into the 3D data. Now, what that means is, you can see it's 35, is as we slowly go up, 35, 35.1, 0.2, 0.3, 0.4, you know, we get that, that's how we get that nice smooth linear. What is actually happening is we're dropping the What's actually happening is we're dropping everything after the decimal place. So our smooth transition is actually jumping up by 1 millimeter every time. It'll be 35, and then 36, 37, 38, 39. So whether we might have, say, 100 steps between our zoom, what we've actually got now is 10 steps, 6 steps, something like that. So that's why it gives it that very steppy thing. Look. Easy fix though. What we can do to fix that is simply multiply all of these values by 100. Like so. And same for focus, like so. And by multiplying it by 100, we move the decimal place back 2 spaces. So 35.2 becomes 3,502, does it? No. It'll become 3,520. 21, 22, 23, 24. And then so that's given us an extra, essentially 100 steps between each focal length, or 100 steps between each millimeter of focus, which should smooth it out nicely. Now, after we make that change, I'm going to need to reset my ranges. There we go. However, we will not need to touch the lens file, because if you remember, the lens file describes the 0 to 1 range and what that translates to in the camera values. Now, what makes that 0 to 1 range doesn't matter, because that's handled in the plugin here. Because we're multiplying the actual value by 100, it's going to be 1,200 for 12 millimeter, and we'll end up with 3,500 for 35 millimeter, just once the camera snaps back. Now, the last handful of things we can do is go ahead and create a media profile for our virtual camera, and make sure that under Genlock, we're selecting Genlock fix rate here, and setting it to whatever frame rate we want to be using. the same as our output. Otherwise, we're going to get, because the tick rate would be higher, we'll get more tracking data than we do frames. So if we're running at 1080-50, but we just have it no genlock, then it might be running at 120 FPS. Then we get 120 frames per second of tracking data and 50 frames of video data, which don't line up very well. So setting this to a fixed rate at the same speed as our video output, then we have 50 frames of tracking data and 50 video frames. And finally, we can marry it all together with the AR tutorial I did earlier, and we have Crunch here now in our virtual studio. However, this virtual studio doesn't exist in this project. You can see it's just the cinema camera, Crunch, and the live link. What we have instead is our virtual studio is streaming over the network along with our tracking data, so that we can then put Crunch virtually, I guess, inside this studio. Exactly the same way we would do it with a real camera tracker in a real studio. Create a couple of nice sequences, add some OSC controls. I did some tutorials on how to control OSC or control sequences with OSC, and all of a sudden you have a virtual camera box that you can use to test all of your AR setups, potentially even green screen as well, just like that. So, hope you enjoyed it, and stay tuned for more.